Okay, so we only have one request for a problem solving session this week. It's for homework 12.4 number 3, specifically on the setup for finding the particular solution. So I went ahead and pulled up problem 3 here and then wrote out the ODE and also the fundamental solution set. That way you don't have to see me work through that when it seems like the person who asked this question already knows how to do it, and I know that a lot of you had had a lot of practice with this already. So, we're jumping in at part 4, where we already have this fundamental set of solutions, y1 e to minus x, y2 e to 4x. And we're to the step of trying to find the particular solution, y sub p, that's going to solve the non-homogeneous problem. So these two solve y double prime minus 3y prime minus 4y equal to 0. And we want to solve the problem y double prime minus 3y prime minus 4y equal to 50 times 3x plus 1 e to minus x is what I was given. And we're told to use the method of undetermined coefficients, which there's a help sheet about it, I guess, but I'll just be following the way we talked about it in lecture video. And remember, this is going to be on the exam. Variation of parameters is not. So even though you could solve this problem with variation of parameters, I do encourage you to try and do it the undetermined coefficient way. So first off, I'm going to guess what y sub p should be based on what my right-hand side of the equation looks like. Oops. I think we usually call that f or g, but I can't remember right now. So if I go ahead and factor out or multiply through this 53x plus 1 e to minus x, I've got 150x e to minus x from 50 times 3x, and then 50 e to minus x from 50 times 1. And my approach is always going to be to just start by guessing that y sub p has that exact same form, but with unknown constants instead of these numbers. So I'm going to say it's ax e to minus x plus, I'm not together today, plus b e to minus x. So I'm just replacing these numbers with the undetermined coefficients right here, a and b, instead of that 150 and 50 we saw. I don't know how to make that go. Okay, and then next up, what we do is the derivative check. And so this is where I would take every function that's in yp right now and then include all of its derivatives as well. But the thing is that ax e to minus x and b e to minus x don't have any new derivatives for us. The derivative of e is just going to be e again, so that'll just give me more of the same. And the derivative of x e to minus x is going to give me like minus x e to minus x from taking derivative on e, plus 1 times e to minus x from taking derivative on x. But the thing is that e to minus x is already there and x e to minus x is already there, so there's actually nothing new. I just wanted to mention this because you all will see sometimes that you do have to add terms here. For example, if I had sine cosine, usually that throws a new term. Or even if I had started with just ax e to minus x, maybe the second part wasn't in my differential equation. Sorry, just the minus one I wanted to delete, not the 3x. Then in that case, taking derivatives on ax would add this b term. but we had it all along. So we'll just go back to that. And then the last thing we do when we're setting up YP is we check if we're copying any terms. And we check those first from the fundamental solution set and then also internally on YP. So that's what I've got so far, but I notice that my y1, e to minus x, copies my b term, e to minus x. And so our approach is always going to be to multiply by powers of x until we get a new term. So this would actually be b e to minus x times x to make it different from y1. And now it's no longer the same as y1, but it is the same as the first part of my yp. So I'm actually going to have to do another multiplying by power of x to make it distinct from that a term. So I wrote this in two separate lines so you can see the difference that I'm having here. I was seeing some people in class today doing like multiplying the whole thing. Like that when they saw that this term b copied y1 there. And it works in this case because you end up having also an exponential term on a. But for example, if my yp had started a sine x plus b e to minus x, I wouldn't want to multiply this unrelated term by x. That would actually cause problems for me. So just so you know, you should not be doing this. In general, that's not going to work out. It just works out in some nice cases. So big takeaway here is that my yp is going to be ax e to minus x plus bx squared e to minus x. And then from here is the part where you would take yp prime and yp double prime to plug into the ODE you want to solve. Y double prime minus 3y prime minus 4y equal to 50 times 3x plus 1 e to minus x. There were some questions in class also of where exactly our yp gets plugged in, and it is to this full equation that we're looking to solve. But since the question was specifically on setup, and I'm sure you all don't want to sit here and watch me take a couple product rules and solve some systems of equations, I'm going to go ahead and stop the video here and get it uploaded so that anyone who needs this information can get this problem started. Remember, if you're having trouble with the systems of algebraic equations in this section, I know we can get a lot of them. Use an online solver. Your exam is going to be like the simplest algebra possible, but I know that sometimes WebWork throws funny numbers at you when it's doing its randomization, and sometimes that makes it a lot harder than it needs to be. So, good luck, and I will see you all in class.